Hi students, welcome back to Abhyaas IIT Preparation channel. I am back with a new video and today we are going to discuss the previous year questions of the chapter Classification of Elements and Periodicity in Properties. So we are discussing the previous year questions of JEE Mains 2024 and in this particular video we will be seeing the questions which came in January attempt. So we will move to the question. The first question. In case of isoelectronic species, the size of F minus, Ne and Na plus is affected by. So you know that these three are isoelectronic species. What is the reason? Because F minus will be having 10 electrons, right? The atomic number is 9 and electrons will be 9, but it is F minus. So it is having now 10 electrons. Neon, obviously it will be having 10 electrons, and Na plus, the atomic number is 11, but it has lost one electron. So it will be now 10 electron. Now you see the number of protons, fluorine will be having 9 protons, right? Positive charge. Here it will be 10 positive charge and here it will be 11 positive charge, right? 11 positive charge. So here what will be having an influence on this particular size of this particular ions? Obviously, it will be the nuclear charge. And here, the nuclear charge will be very high, right? The nuclear charge will be very high because the 11 protons are pulling 10 electrons towards the center. Because of that reason, you can see that there will be significant reduction of size of Na plus. So, we can say that the factor which is affecting the size of this isoelectronic species is nuclear charge. Fine. I hope you have understood. So just see how this particular number of electrons and protons are changing according to the ion, and you can understand that nuclear charge will be having an effect on its size, right? Now we will move to the next question. Here you just see lowest oxidation number of an atom in a compound A2B is -2. The number of an electron in its valence shell is. So you can see here it is a diatom, like we are having a diatomic molecule, and you see -2. -2 is the oxidation state. So when you are thinking about -2 oxidation state, we will be getting the thought of the element. Which element? It will be oxygen, right? Oxygen. So here the same logic we can apply and we can come at a conclusion. For oxygen, if you take, you are having totally 8 electrons and 6 electrons in the outermost shell, right? So the number of electrons in its valence shell will be 6. So if you take the case of oxygen with atomic number 8, 2, 6. 6 will be in the outermost shell and it will be 6. Otherwise, you can think like this. The octet rule. Octet rule, in that a particular species tend to have 8 electrons. Now 8 minus 2 will be having 6. So the number of electron in such a species will be 6 electrons. That means the valence electrons will be 6, right? Or number of electrons in valence shell will be 6, right? Now we will move to the third question. Both metal and non-metal exist in, it's actually D block elements. So you know that in D block elements, there is not both metals and non-metals. It will be only metals, right? In D block elements, it will be only metals. So it is a false statement. And what is the second statement? Non-metals have higher ionization enthalpy and higher electronegativity than the metals. It's right, right? This ionization energy and electronegativity will be higher for non-metals. It is a right statement, right? So here the first statement is false and the second statement is true. So which is the right answer? Statement 1 is false but statement 2 is true. So you have to go for the second option. Now we will be seeing the third question. So we have completed the third. Now we are going to the fourth one. The strongest reducing agent among the following is. Right, so you think about the reducing agent. What a reducing agent will be doing? It will be donating electrons, right? So that is a thought you have to have in your mind when you are thinking about reducing agent. That means it will be donating electrons. So just see who among this can easily donate electrons? So here we are having this particular elements, and among this particular bismuth, right, it will be actually coming towards the down of the group, right? It will be at the bottom of the group, and if it is at the bottom of the group, what is the thing happening? Atomic radius is increasing, right? If atomic radius is increasing, ionization enthalpy will be very less, right? And also the bond length is increasing, so easily electrons can be what? Donated by this particular BiH3. So we have to say that BiH3 will be the strongest reducing agent among the following. So I hope how we have arrived at the answer. The thing is that donation of electrons is done by reducing agent, and among this BiH3 can easily give the electrons, donate the electrons, because of the reason the atomic radius of Bi is more and ionization energy will be very less for BiH3. Because of that reason, BiH3 can easily donate the electrons, right? Now we will be moving to the next question. From the given list, the number of compounds with +4 oxidation state of sulfur. So here I can easily say this particular H2SO3 will be having +4 oxidation state, SOCl2 +4, SO4 will be having +4, and here it will be +6, here it will be +6, +6. So how can we calculate this particular oxidation state? So the answer will be 3. 3 will be having +4 oxidation state. So I will take the example of this particular H2SO3. So H2SO3, we have to find out the oxidation state of sulfur. So what you can do, we know that the charge of hydrogen, we know that it is 1, so it will be 2 into 1, right? Plus we have to put this S as X. Then you know that oxygen will be having -2 oxidation state. That means 3 atoms are there, 3 into -2, and you have to equate it to 0. Now 2 plus X, 3 into -2, it is -6 is equal to 0. Now we can see that X is equal to this particular 6 will be going to the other side, 6, and 2 will be remaining here. So 2 plus X is equal to 6. Now X is equal to what? 6 minus 2. We will be getting +4. So H2SO3 I have shown. In the same manner, if you look for this particular oxidation state, you can see that SOCl2 and SO4 also will be having +4. SO4 also I will show you. SO4. Sulfur we have to find. Put it as X. Now fluorine will be having -1 oxidation state. -1 into 4 is equal to 0. Now X is equal to what? +4, right? So like that you can find the oxidation state of each compound. And here H2SO3, SOCl2 and SO4 will be having this particular +4, and others will be having +6. So the number of compounds having +4 oxidation state is what? 3, right? So our answer is 3. I hope you have understood this question. We will move to the next one. Here is an assertion and reason type question. We will see what is the assertion. The first ionization enthalpy decreases across a period. Is it right? You know that across a period, from left to right, atomic radius decreases, right? And you know that atomic radius decreases means the ionization energy will be increasing. So this particular assertion is wrong. The first ionization enthalpy, it is actually increasing, not decreasing. It is increasing. So we can say the assertion is wrong. It is false. Reason: the increasing nuclear charge outweighs the shielding across the period. Right, it is right. The increasing nuclear charge is outweighing the shielding. That is a right statement. So we have to say that A is false but R is true. A is false but R is true. So that will be your answer. Now we will move to the next question. Here also we are having two statements and we have to find whether it is right or wrong. The electronegativity of group 14 elements from Si to Pb gradually decreases. Okay, so what is the thing happening here? That you know that you are having the elements carbon, you are having silicon, you are having germanium, you are having tin, you are having lead. So if you take the electronegativity values, the ionization enthalpy values, you will be having these numbers. Okay, now we can see that, sorry, I just changed the question. Here it is. You are having carbon, you are having silicon, then germanium, then you are having tin, then you are having Pb. So it will be 2.5, 1.8, 1.8, 1.8 and 1.9. So it is what? The electronegativity values, right? These are the electronegativity values. So in this case, you can see that it is not gradually decreasing. So first we are having 2.5 for carbon, then it is 1.8 for germanium, silicon and tin. And after that, at last, lead, Pb is having 1.9. So we cannot say that it is decreasing. At last, you are having a slight increase and the three are having the same values. So we have to say the first statement is false. What is the reason? Because we know the electronegativity values and it is not gradually decreasing. Now, going to the second statement. Group 14 contains non-metallic, metallic as well as metalloid elements. You know that P block or 14th elements, 14th group will be having these three: metals, metalloids and non-metals. That is a true statement. So here we have to say that statement 1 is false but statement 2 is true, right? Moving to the next one. The element having the highest first ionization enthalpy, okay, first ionization enthalpy, that means which will be having more stability, will be having higher ionization enthalpy, right? So that means electron will be having difficulty to move out of that particular atom. In that case, we have to say that nitrogen, among this nitrogen, what is the configuration of nitrogen? 1s2, 2s2, 2p3, right? 2p3. So here you know that if you take the p orbital, p subshell, you will be having 3 orbitals and you are having a half-filled configuration, and from this half-filled configuration it is difficult to remove an electron. Because of that reason, the first ionization enthalpy will be highest for nitrogen among this, right? Because of a stable electronic configuration. So nitrogen will be your answer. Next question. Here also we are having two statements. First one is that fluorine has most negative electron gain enthalpy in the group. No, right? It is not right, because fluorine's electron gain enthalpy is what? It is 328. And in the same group, right, in halogens, you are having chlorine with 349. Right, electron gain enthalpy of chlorine is 349. Because of that reason, I can say statement 1 is wrong. Now statement 2, oxygen has least negative electron gain enthalpy in its group. That is right. That is right. So we have to say that statement 1 is false but statement 2 is true. So the fourth option will be your answer. Right. Now the next question is a very simple question. We are having this particular concept in our mind, this particular reason. What is that? Anomalous behavior of oxygen is due to its small size and high electronegativity, right? It is actually a thing that we are studying many times in that chapter. It is small size and high electronegativity of oxygen makes it anomalous, right? So that was an easy question for you. Now we will move to the next question. So here you are having an assertion and you are having a reason. There is a considerable increase in covalent radius from N to P. However, AS to BI, only a small increase in covalent radius is observed, right? It is right. From N to P, there is a considerable increase in covalent radius. But after that, you will be having what? less. Only a small increase is found out. Is it right? It is right. So at first you will be having a larger covalent radius, increment of larger covalent radius from N to P, but then it will be lesser. But there will be increment, but it will be in what to say, smaller quantity. So that is a true statement. Assertion A is right. Covalent and ionic radii in a particular oxidation state increases down the group. Right. It is also right. Covalent and ionic radii will be in a particular oxidation state will be increasing down the group. That is also right. So can we say it is the correct explanation of A? No, it's not right. Both A and R are true, but R is not the correct explanation of A. That will be your answer. Now going to the question 12. So you know that this anium will be 1, 1, 1, right? By that particular name, we can know that anium will be 111. So they are asking, then the element belongs to nth group of periodic table. That means which group? First group, second group, like that we are having the group. So to which group this particular 111 element belongs? So you just see what is the last two digits. So according to that, we can easily say to which group it is belonging. So in this case, 111, it will be belonging to the 11th group. Suppose it was like 117, it will be belonging to 17th group. Okay, so in such a case, you can easily find out what is the thing. You have to see which is the last two digits, and that numbers will be giving you the, or that particular number will be giving you what? The group number. So here in this case, the group number will be 11, right? Now, this is the last question in this particular section. The thing is that an assertion H2TE is more acidic than H2S. The recent bond dissociation enthalpy of H2E is lower than H2S in the light of, okay, so the thing is that bond dissociation enthalpy of H2E is lower than H2S. So first thing, H2E is more acidic than H2S. Is it right? The thing is that tellurium is having a higher atomic radii, right? It is having an higher atomic radius than sulfur. So this H2TE can easily release the hydrogen. It can easily release hydrogen. The reason is that what? It can easily dissociate the bond because of higher atomic radius, right? The force of attraction will be less in the case of H2E, and because of that reason, hydrogen can be easily released. So if something is easily releasing hydrogen, we can call it as more acidic. So definitely H2TE is more acidic than H2S. And what is the reason? The same reason, the bond dissociation for H2TE, tellurium, is more because of the higher atomic radius, right? So we can say that both assertion and reason is right. So here, what will be the answer? Both A and R are true, and A is the correct explanation, or R. Okay, we have to say that R is the correct explanation of A. So we have to go for the second option. So here we have come to the end of first section of this particular chapter, and we have discussed the questions of January attempt. In the following video, we will be discussing the questions of April attempt. I hope this particular section was easy for you. It is more like concept based. We don't have much calculations to do, but if you are studying that concepts, definitely this particular chapter will be giving you a lot of marks. So study each and everything, every concept belonging to this chapter, and definitely this chapter will be bringing you a lot of marks in the examination, right? So don't waste your time. Prepare hard for your coming JEE Mains examination, and we will be seeing you in another video. Thank you for watching.